What I do is I know the case of low, high, higher, and high, low, lower. I remember those for bright and dark, and then I just switch them for the other ones. So this is example number 2. So this is low, high, back to low. And we see them, so these are bright. So 2t equals m plus a half lambda in the film. And the lambda in the film will be the wavelength of the light in air divided by 1.2, 1.50. Right? I can do this right away. Yes? Now, why is this dark? Why is it dark over here when the thickness is like 0? Because for this, if I consider dark, right, then 2t equals m lambda in the film. 2t equals m lambda of the light in air divided by the index of refraction of the light in the film. So 2t equals m lambda of the light in air over 1.5, right? Now, what happens if I choose m equals 0? What would be the thickness? 0, right? So 0 thickness corresponds to dark. And I can think of this problem, it's drawn like that, but I can think of this problem pretty much like this. Like I have here water. And, this doesn't have to go up like that. I can just think of it like this. This is the oil, and this is air. And in this corner over here, the thickness is 0. So notice that you don't get 0 thickness for the formula for bright, because if I plug m equals 0, I'm going to get that the thickness is something other than 0. So this is not satisfied when the thickness is 0. But this is satisfied when the thickness is 0. That's why from over here, it's dark. Yes. Now, what you see here is this. I don't have the yellow, so we have blue, yellow, red. So we have blue, I guess we have orange, which I'll use as yellow. So what you see is this. You move off over here, and then there's a line of blue that corresponds to this thickness, a line of yellow that corresponds to this thickness, and a line of red that corresponds to this thickness in the film. This is the film. The oil is the film, right? And then you move off, more thickness, and then you see another blue that corresponds to this thickness. Another yellow line that corresponds to this thickness. And another red line that corresponds to this thickness. Now, these are the smallest thicknesses for the colors that you can see, right? That would be this formula. And for the smallest thickness, what will be the value of m for this group over here? 0. Yes? And then you keep increasing the thicknesses, right? Because if m gets bigger, the thickness will get bigger. Then you have this other group. And this corresponds to m equals 1. Right? So, what does it say? You have a thin film of oil with varying thickness floats on water, right? 1.5 index of refraction for oil, 1.33 for water, air is 1. When it is illuminated from above by white light, so you have all the colors, right, in the visible spectrum, the reflected colors are shown in the figure below. And now in air, the yellow light is 580 nanometers. So we know that the light, if I consider yellow light, so this is for dark over here, right? So that's not what I'm going to be using. I just wanted to show you why zero thickness gives you dark. So if you consider yellow light, the wavelength of the light in air is 580 nanometers, that particular light. All right? First question. Why are there no refracted colors at point A? Okay, I guess I answered that already, right? Because at point A, the thickness is 0, and given that we have low, high, low, 0 thickness matches the formula for dark, so it's dark. Second question, what is the oil's thickness at point B? That corresponds to yellow, is the second yellow line. Point B, what's the thickness? So what we want to know is this particular thickness over here, this one. What is this thickness? Well, it's going to be bright with M equals 1 when the wavelength of the light in air is 580 nanometers. So all I do is I use the formula for bright, which is this one, with M equals 1. So I have 2T equals 1 plus a half. And the wavelength of the light in air is 580 nanometers. I don't even have to convert 2 meters, and then divided by 1.5. So the thickness will be 1 plus a half. It's going to cancel this, right? And then 580 divided by 2 is what? 290?
Yeah.
Wow, you don't even need a calculator to do this. Look at all the work that I did. Boom, boom, boom. Quick. Of course, if you read the question, this problem tends to be, so the bad thing about these problems is that if in a test, I give you a problem like this, and first of all, you use the formula for dark when you're supposed to be used the formula for bright, that's very bad already. And then the other thing is, what value do you use for M? And the other thing is, in all of these formulas, you want the wavelength of the light in the film. So usually, well, when people make mistakes, they forget. They use the wavelength of the light in air, not the one in the film, unless the film happens to be air. Then you're locked out. But one mistake over there, so if you use the correct formula, then you get some points. If you use the correct value of lambda, you get some more points. And if you use the correct value of M, then you get full credit for that question. But if you start off with the wrong formula, I can't really help you. It's like, that was just wrong. So just, read it carefully. Like over here, so as you do many of the problems, then you learn to figure out when it is that they want dark, when it is that they want bright. So this is called thin film interference. So I'm done with this chapter. The next chapter is diffraction.